Hi. So we are all here, so I can start welcoming everybody to today's second roundtable on generative AI and law series hosted by the Global Legal Tech Hub. So I'm delighted to see that there are participants from all over the world, and most probably that reflects also what reflects our speakers and where our speakers are based. And on the previous talk, you know that on Monday we started this series with two fantastic presentations from Jennifer Goodard, based in Barcelona, and Greg Miot, based in Paris. Today we are going to have our roundtable getting data ready with one speaker, Damien, based in Twin Cities, and Uwais, based in London, plus myself, an Argentinian based in Milan, Italy. So that gives us an idea about how global the Global Legal Tech Hub actually is. So going to today's session, getting data ready, I consider it a critical roundtable, because there is a lot of magical thinking around, and most probably we obviously, after we saw this magical solution ChatGPT in November 2022, we expect the acceleration to be as easy as entering a question and the parrot providing us a magical answer. It might be a spoiler alert, but actually it's not so easy to take a proof of concept or some testing or some use cases to actual production ready and enterprise ready solutions. It takes a little bit more time, and our speakers are going to help us understanding these critical aspects. Those who are going to reap the benefits and are still the ones that get their data in order, their house in order, or as Uwais loves to say, puts in order the ingredients before actually baking the cake. Actually, but I saw that lately you are talking about the garden, and I'm not good with garden analogies. So maybe Damien, maybe you are going to help me with gardening. So getting our cake in order. As you notice, it's going to be a friendly roundtable with two good friends and generous speakers from with a track record, a long track record in the legal tech space. What you can expect today, a little different from what you saw with Jennifer and Greg, because the subjects obviously it's going to be a little bit more focused, and we thought that it's better if we let one of the speakers develop one of the subjects and then the other. But this is the theory. Most probably in the practice, it might go differently. The idea is to start with Uwais, that is going to explain us how to get our data ready, and it's more educational and a clarification about all the work that in particular law firms or corporate departments could or should take into consideration, training or adding their own materials to the LLMs solutions out there. I'm not an expert in this field, and I'm as curious as everyone on his talks. After we develop this first piece, and we are going to go to Damien and the SALI Alliance approach to enrich data with the common incredible taxonomy that they have developed for years, I might say now, that actually has had an amazing acceleration because of these GPT developments. And so Those are the two subjects today. As I mentioned, I'm as curious as everybody else to see this roundtable develop. Please do ask questions, because it makes so much interesting for everybody. Obviously, it makes it gives some adrenaline to the speakers, and unfortunately, as we cannot see everybody else, all the participants, it makes us feel less lonely if you ask questions. So I guess that's all for my 5 minutes introduction. I will, without further delay, I will leave the floor to Uwais to take us into this introduction and deep dive on behind the scenes.
Sure.
Please.
Thanks, Alejandro. Can I share my screen?
Yes, please.
Sure. Just give me 1 second. Let me see if I can get this working. Great. Can you see my screen?
Yes.
Awesome. Nice to meet everyone. Thank you for joining, and hello. I just wanted to say thank you to Alejandro and the team for putting this webinar together and giving me the opportunity to share something and a chance to educate the community and the industry about some of these conversations around how we can go about better preparing our data for use with generative AI. So there's going to be a lot of memes throughout this talk, so it's a bit of a lighthearted one, but it's more kind of to try and draw on some of the questions and the conversations we should be thinking about. So everybody's going crazy and losing their minds over generative AI in the legal space and large language models. But then there's that question about when it comes to the practice of actually building these solutions or developing these systems, maybe we haven't thought through all of the questions and the problems. So hopefully through this presentation, I can share some insights and hopefully we'll be in a better place to try and focus on these conversations. So we're going to touch on some things around data and generative AI. This is more of a learning exercise. So there's going to be a couple of definitions, and then we're going to move through an analogy. And Alejandro mentioned it. I didn't even let him know there's going to be a garden analogy, but we're going to be talking about a garden. So hopefully he'll be able to follow along with the analogy. And then we're going to try and demystify some of the magic and the mystery behind generative AI, so we can actually understand how some of these systems work, and then get a bit of a behind the scenes peek in terms of how we can try and customize some of those, use our internal data to customize those systems. So a brief introduction to me. My name is Uwais Iqbal. I'm a data scientist, and I've held roles across legal tech companies and legal tech startups and a corporate innovation lab. And I've been doing AI in the legal space for over half a decade now. And then quite recently, I set up my own company, Simplexico, and we've been focusing on helping the legal sector get their head around AI to try and make the most of the technology in a meaningful way. Okay, everybody ready to get started? Awesome. So in very lawyerly fashion, I'm not a lawyer, but I always think it's a good place to start with definitions to try and set the tone and get everybody on the same page in terms of what we're speaking about. So everyone's using the term artificial intelligence, but how many of us actually are familiar with a definition of what this technology actually entails, and what do we actually mean when we speak about artificial intelligence? So from a very broad perspective, not speaking about particular use cases, but speaking about the technology as a whole, we can think of AI as a technique that uses machines to replicate the problem-solving and decision-making capabilities of the human mind. So the key thing here in the definition is this ability to replicate what humans are able to do when it comes to problem solving and decision making. And I think the level shift that's happened with the new advancements in generative AI is now for particular tasks that were solely in the human domain when it comes to generating content, drafting, etc. Now machines can also be used for those tasks. So there's this idea of using machines to replicate something a human can do. And then when we break down the definition, I think it's always important to remind people of the artificial part. So just like Maggie in the Giphy, she's just following Marge and imitating her without really understanding any context of the road or what's happening behind. The same as with these models, they're just massive mimicry machines and imitation. And then the intelligence part of the definition looks at what we want to try and replicate from a human perspective. So what we have as in any kind of given case when it comes to AI is that there's something we can already do as human beings that involves some level of capacity, intellect, skill, expertise. And then we want to leverage machines to be able to replicate some of that behavior. So the intelligence part means that we want to try and replicate something that only humans are able to do, and skilled humans for that matter. So that's a brief overview of AI. And then let's kind of take it one notch up. And when it comes to generative AI, what is it and what do we actually mean when we talk about generative AI? So like there's a short answer and a more detailed answer, which goes into a bit more technical specifics. So generative AI refers to AI systems that are capable of generating content. That's where the generative part comes from. And then this content can be in different forms, in text, images, and audio, etc. So when you think about it, generative AI, it's a particular branch of deep learning, as demonstrated in this visual. And then there's an overlap with natural language processing, which looks at how you can use language to replicate some of these. The NLP looks at how we can replicate tasks involved with language. So we want to apply AI to language problems. So we have this overlap with NLP and deep learning, and then we also have this overlap with generative AI. So this is we have lots of buzzwords. We have NLP, deep learning, AI, machine learning, etc. So hopefully this will help you position where generative AI fits in that picture. So when we step into the more detailed answer around generative AI, I think this helps to open up thinking about what generative AI models actually do and how they work under the hood. So up until prior to generative AI, a lot of the machine learning models were known as discriminative models. And then the way these discriminative models work and function is they effectively organize data to try and spot patterns. But then at the very basic level, they try and understand what the differences and similarities are between these data points to try and create some sort of boundary. So if you're training an image classifier to detect dog images versus cat images, it just learns the features which are particular to dog images and the features which are particular to cat images, and then it learns to make a distinction between the two. And then up until now, that's been very good. The discriminative models have been really, really awesome. But what happens with generative models is a different type of process. So if we're trying to build something to classify dog images and cat images, what a generative AI system does is it learns to map the entire data set. So it develops an understanding of how dog images look across all of the data set it's seen. And then it learns an understanding of how cat images look across the entire data set of data points it's seen. So because it has some level of semantic understanding of what a dog image is, what a cat image is, and the differences and the subtleties between different dog images, you're able to get more learning, I guess, more bang for your buck when it comes to learning from these models. So these generative AI models, they can go a step further and compose things it's already learned to generate examples it's never seen before. So it knows particular breeds of dogs have particular facial features, and then it can compose those to generate a new image of a dog, for example. So this is a bit more of a technical distinction. So generative AI models have this kind of broader perspective of modeling the data in this way. So if we look at an example of something generated by an a generative AI system, hopefully this will make it clearer. So this is an image generated from OpenAI's DALL-E 2 system. So you put in a prompt and it gives you back an image based on your prompt. And the image is completely generated from the AI system. So here's the prompt that was used. So a modern sleek Cadillac drives along the Gardiner Expressway with downtown Toronto in the background with a lens flare 50mm photography. So what's happened, if we take this understanding of generative AI models mapping the entire data set and learning kind of semantic markers and being able to compose new images and new content, what's happened is that from the training data, the generative AI systems learned what each of these things mean. So it knows what modern is, it knows what sleek is based on all of the images it's seen, and it knows what a Cadillac looks like in a general sense by looking at all of the examples of images which have Cadillacs in them. And then in this way, it can kind of like pick out the segments from all of the data it's seen before, merge them together in this composition action to create a new image. And then because it already has an idea of what images tend to look like, it can create a fully formed image without any ruptures or any breaks in the image itself. So generative AI systems go that step further in being able to generate content, but they do it in a way where they draw on all of the knowledge and the data they've seen before. So it's not as though these systems are doing something magical. It's just that they've learned how to optimize and make the most of the data they have available. So that's a brief introduction to AI and generative AI. And I think there's some kind of key terminology which is important to be familiar with when speaking with data before we jump into a few of the other conversations. So data comes in many different forms, shapes, and sizes. And one way we find people speaking about data is in terms of its modality. The modality is very simple, but it's a complex term, so people get stuck on it sometimes. So data can take a number of modalities. So for example, you can have data in a text modality, in an image modality, in a speech modality, in a numerical modality. And then predominantly for us in the legal space, a lot of our data is in the text mode. So that's what we're primarily interested in. And sometimes you might hear people speaking about something being a unimodal data set or a multimodal model. What does that actually mean? So a unimodal data set refers to a data set that contains only a single data modality, okay, just one data mode. So if you take a data set of legal documents, that would be a unimodal data set because it only contains textual data. It doesn't have images or any other modes of data. And then multimodal data goes a step further, and it contains multiple modalities. So a data set with a mixture of images, text, and other modalities would be known as multimodal. So if you have an image captioning data set, that would be a multimodal data set because it has images as well as text, so it's a bit more complex. So that's just a brief introduction to unimodal and multimodal data. And then there's these two other terms which they've fallen out of vogue now, but they were being thrown around in the previous wave of AI solutions. This idea about homogeneous data and heterogeneous data. So homogeneous data refers to data that's a collection of samples where between each of the samples, the samples are very, very similar in nature. They're similar in kind. So if you take this example, all of the data points are circle, but then each of the circles have their own characteristics, their own features, for example. And if you have a data set consisting of solely employment agreements, for example, this would be considered a homogeneous data set because all of the data samples, for example, are of the same kind. They're all employment agreements. But then between the employment agreements themselves, you'll have a level of variation. Some will be drafted in a particular way. Some will be more permissive. Some will be more restrictive. So you'll have natural variation in the data. And then you have what's known as heterogeneous data. And heterogeneous data refers to data sets where the samples that make up the data are very different in kind. So you have triangles, you have circles, you have diamonds, you have pentagons, you have hexagons, you have a whole mixture of different things. And if you take a data set from e-discovery, for example, it might consist of emails, letters, contracts, court filings, briefs, etc. And all of that data has different shapes and forms and of different kinds. So that would be a heterogeneous data set. So when we have a perspective of like just having the language to talk about our data in the right way, I think the conversation becomes much more informed because you can have more particular, you can be much more particular and concrete about the particulars of your data set. Okay, so that's some preliminaries. And now moving to the analogy that Alejandro has been waiting for, we're going to step into the garden of not of Eden, but of E-Dayton. Alejandro touched on it previously, but the knowledge management professionals for, I guess, over a decade have been talking about data transformation projects. And now with the recent wave of generative AI, people have been doing things like purchasing the shiniest generative AI tool or doing things like hiring a prompt engineer. And then there's always the people left in the lurch who are actually talking about doing these transformation projects with data, which is unfortunate. But hopefully this is a conversation contributing to a step in the right direction. So to the analogies. So what goes into making an AI model? Before we can talk about how data can be applied in a generative AI sense, let's talk about an AI model. So an AI model is actually an end product. It's a process of bringing together different components in a particular way and combining them. So if you think about cooking and a chef in a kitchen, we can draw this very similar analogy. So a chef, a data scientist, he combines the ingredients, the data. So the analogy is that your ingredients are your data in the cooking analogy. And then you combine them according to a recipe, which is the underlying algorithm. And the chef cooks the meal on a stove and he prepares it in the kitchen, right? And then once the meal is ready, it can be served to a customer and he can enjoy his meal. So the key part of this analogy here is to think about AI as a process. So ChatGPT, for example, despite it being so performant and so magical in what it can do, it's the end result of a process that can be replicated and reproduced. And it all comes down to the ingredients that we used. Like the food is only as ever good as the ingredients, they say. So when we take this perspective of data as ingredients, we can like extend the analogy to think about like the data garden. So if a chef is running his kitchen and he has his he has his garden, he'd want to use the ingredients from his own garden which are fresh, so that his customers can have the best tasting food. So on the one hand, people speak about data being similar to oil. And then just as with oil and preparing that, there's a number of steps that need to be considered when making that ready. So we can break down data into 3 different states along this process of creation of value. So there's unstructured data, semi-structured data, and structured data. So unstructured data is typically how you find data in the wild, and that's where most firms are at in terms of the data within their organization. It's a bit of a jungle. Everything's everywhere. Nothing's been organized. Nothing's been categorized. It's a bit of a mess. The unstructured data, a typical example of that would be a set of contracts that live within a document management system. It's just free-form text. There's no kind of structure around it that can be used. So that's like an untended garden, which is in need of love and care. And then semi-structured data is data which has undergone some refinement, but still has some rough edges. It's like oil which has been extracted from the ground, but still needs to be purified, or when the chef, he picks vegetables from the garden, but they still need to be washed and peeled before he can actually use them in his dish and cook them. So if we have an example of a semi-structured data set, that might be a document management system with some contracts, and with those contracts, there's some associated metadata about the parties and the date of signature, but it's not as structured as it could be because there's some work that needs to be done before the data can properly be used and mined. And the holy grail and the highest step in the value chain is this idea of structured data. And then this is where data has been prepared so that it's ready to fuel AI models, it's ready to fuel applications, it's ready to be used in analytics workflows. And it's, by analogy, it's oil that's been purified and ready for consumption, and it's vegetables which have now been peeled, chopped, and diced, and washed and made ready, so that now the chef he can do his work of preparing the actual dish. So an example of a structured data set, it's a set of contracts with all of the relevant fields extracted into a table. And then structured data usually comes in the form of a CSV file or a database table. And that's usually the starting point before enabling higher level insights and higher level intelligence from data by way of analytics, statistics, or through machine learning with AI models. And the important difference to understand here is that oil is a consumable resource. So when you fill up your car and you fill up your tank, when you drive the car, you run out of petrol or you run out of fuel. When you create a dish, you've used up those ingredients, so you can't use them again. But data is interesting because as you move up this value chain of increasing the value creation of data, then you can reconsume that data as many times as possible and it will still be there. So it's a persistent resource. It's not a consumable resource. So any investment which goes into progressing along this value chain of data, it's a worthwhile investment because that asset of intellectual capital within an organization will always be something you can come back to and use for different purposes and fuel different applications. So data is the garden that just keeps on giving. We just have to get into that garden and start tending to it. So that's a bit about the data garden. Now, if we come back to generative AI and we try and step behind what these models actually do. So these models are trained in a number of stages. So the pre-training stage is where the model is trained on a vast collection of data from the internet, usually, to develop a general understanding of how language functions. And then these models can then be taken and then fine-tuned on particular data sets of a specific domain practice area so that it can be focused for a particular task. And now this fine-tuning, it can happen in a number of ways. And then this is where we get into the nitty-gritty of actually uncovering how we can leverage these models with our data. So there's what's known as unsupervised fine-tuning. And then this is the general speak where people speak about fine-tuning. And then this is where you give the model a corpus of unstructured text. And then from there, that corpus is usually domain specific or speaks about a particular about a particular thing. So for example, you can take a general purpose model which has been trained on the English language, and then you want to teach the model the specifics and quirks of legal language. So you'll give it a domain specific data set. That process is known as fine tuning. And then the more specific you make that data, the more targeted the model's learnings will be and the more focused it will be able to focus on these specialized applications. And when it comes to unsupervised fine-tuning, all that's needed is a corpus of raw text documents, which are relatively easy to source. So you don't necessarily need unstructured data to get started with this type of fine-tuning. The more kind of enabling fine-tuning is what they did with InstructGPT, which is one of the forerunning models before ChatGPT was released. So this is known as instruction response fine-tuning. And then the way this works is that you create these pairs of instructions and responses, and you train the model on these pairs, and through that, the model develops an ability to follow particular instructions and particular commands. And then this is why you can see these models doing general actions like summarization, drafting. It's because they've been trained on these pairs of instructions responses. So it's learned a general understanding of what does it mean when someone says draft? What does it mean when someone says summarize? So all of this is brought into the training data that these models have been trained on. And here's some examples. So we've been doing some work, and we have a paper coming out next week around instruction response tuning for legal content. So an instruction can be something like this: draft a renewal term clause for a marketing affiliate agreement between two parties with specific renewal terms of successive 1 year. And then the response is the actual expected drafted clause. So we can create these pairs, and then once we create these pairs, we can feed them to the model so it can be trained. And then we can do that for other tasks like classification and extraction. So that's the piece around fine-tuning these models. And when it comes to concerns around using these models, there's usually these layers of concerns around data protection, security, and confidentiality. And the challenge is that although people are eager to use these tools, if we don't take into consideration these concerns, there will be negative consequences. So everybody's familiar with the incident that happened in the US with ChatGPT fabricating case citations. So if we don't take into consideration those concerns, then there's problems which can come about. So there's a whole host of practical and justified concerns around this area, but then they can break down into three main areas. One is around IT infrastructure within an organization to enable this like technical transformation. Then there's concerns around information security, and then also around data protection. And with closed source models with third-party vendors, the struggle is always around sharing that data with the vendor. But then what's happened within the open source community is that a lot of the capabilities are being replicated with models that are publicly available. So now these models can be brought in-house, and still that transformation can be enabled. So getting ready for using data with generative AI, it's really about doing the common sense things around data that should have already been done with an organization. There's no silver bullet. It's just doing what's on the list effectively. So things like, do you have a centralized data store for your data, or is data scattered across different databases and applications? Is there an easy way to access data with the proper controls in place? Has sensitive data with PII been anonymized for internal use? And with client data, are there the right confidentiality arrangements to allow you to use client data for training? And on the IT side, do you know how to create secure environments on the cloud to host your data? So there's these kind of general things which have been in the background, and I think they're the most important things that get paid attention to if you want to enable transformation with generative AI. And then when it comes to using open source foundational models, for unsupervised fine-tuning, this can be done with general data that's available within the organization. It doesn't have to be structured. But the interesting thing is where instruction response fine-tuning comes into play, because a lot of the internal content, the internal knowledge management content that tries to capture tacit knowledge, that can be recast into instruction response pairs. And then if you're able to do that, then you can go from tacit knowledge to explicit knowledge in the form of instruction response pairs, and then train a large language model with that explicit knowledge of doing these particular tasks and then tasks and these particular instructions. And then you can create scale for accessing expert knowledge within the organization and scale in that way. So that's just one potential application of how this data could be applied with generative AI for these language models. I think I've run out of time, but thank you for listening. I've been rambling on for a while. If there's any questions, feel free to jump in. And if you've got any feedback, comments, or criticisms, you can reach out to me. And I'm posting about this stuff quite a lot on LinkedIn. So feel free to get in touch with me.
Amazing job, actually, with Damien. We were like, this is music to our ears. We were thinking, this is beautiful introduction, and actually for people that would like to see a data scientist in action, this has been a practical example of a data scientist that can explain things actually. So superb.
Thank you.
while we digest so many terms and actually, obviously, while we prepare some questions, I suggest to jump into Damien's SALI Alliance and presentation, and then obviously do our best, because there is so much material in this talk that actually we could continue forever. But let's move on to the next subject, sure. And then eventually we go back with questions in about 20 minutes.
Great. Thank you so much, Alejandro. And Uwais, that was an excellent 20 minutes. I think that you've condensed a whole day's worth of learning into 20 minutes. So congratulations on that. At the risk of providing yet another analogy, actually building Uwais data is the new oil. Let me give another prism to be able to describe what Uwais was talking about. That is, if data is the new oil, first you need to be able to extract the oil, and then you take that raw oil and then refine it. Is it going to be jet fuel, or is it going to be gasoline, or is it like petrol, or is it going to be, and how is it going to be piped to the customers? And what is the product? Maybe the product is petrol or gas, or maybe it is plastic. What is the product that's going to be done? And of course, you need to send that product to market. So in the sense of legal data, which Uwais, Alejandro, and everyone on this call, we need to extract it from the government. We need to extract it from the courts, and we need to extract it from the law firms and the corporations that have the legal data. Then once you extract it, a lot of what Uwais was talking about is being able to take that raw data and make it usable, to be able to make it semi-structured. And of course, one way to take that semi-structuring is tagging. And I used to work at Thomson Reuters, and Thomson Reuters had thousands of people that were tagging and making structured data out of unstructured data, legal data. And of course, OpenAI and others have made that much easier. And of course, the SALI Alliance, which I'm going to be talking about now, is a way to make that even easier yet, a way to be able to standardize that structure. And then you must take that distilled data, that is the now tagged data, and you have to get it to customers. Of course, you have to get it to customers either through a website, maybe a client portal, or through an API as raw data feeds. That is the pipeline. And of course, that is, coding is becoming cheaper because things like Copilot and others, you could be able to say, create a API call from this thing to that thing, and it will output some code. So that pipeline is coming a bit easier. And then you have a product. What do you want to do with it after you now have this well-structured data? And for that, you need lawyers. That you need people to say, what is the output that the lawyers want? And you need product people. To be able to say, the lawyers are the users, or the paralegals are the users, or the in-house counsel is the users. What is that product? And of course, you have user experience. How should that feel? How should that look to people? And then, of course, you have sales, reputation, relationships. Each of these things is the end of the pipeline to get it to market. So really what we're talking about for the SALIs is the refinery. And that's what Uwais said, you take the raw data, and then you need to refine it and tag it up and get it ready for the large language model. So that's what we're going to be talking about now. By way of introduction, I've been a lawyer since 2002. I clerked for judges at the state and federal level, and the appellate and district court level. And I also worked for a large law firm, Robbins Kaplan. And so as part of that, I represented a large corporation in the United States called Best Buy. It's a retailer. I represented victims of Bernie Madoff Ponzi scheme. I also sued JP Morgan over the mortgage-backed security crisis of 2008. So I had a long litigation career, but I've also been a coder since 1985. So I have the law plus tech background. My mom loves this photo, by the way. And so the number of lawyers that also worked for big law firms, that also clerked for judges, who are also involved in technology, there aren't many of us, and there's a very small group in that. So I'm part of that small group. I worked for, so in 2015, I pitched Thomson Reuters. I said, here's some legal tech that can change the world. You should build it and hire me. They were dumb enough to do that. So I worked for Thomson Reuters building this big thing. After that, I worked for a cybersecurity company where my biggest thing was that Facebook hired me and my company to investigate Cambridge Analytica. So I spent a year of my life, Monday through Friday, on Facebook's campus working with Facebook's data scientists and my former FBI, CIA, NSA people to figure out how bad guys use Facebook data. I did that for about a year. I have a TED Talk. I've copyrighted 471 billion melodies with a B. And my day job these days is with vLex. And vLex's products include Fastcase and Docket Alarm. And if you think about that data is the new oil paradigm, we have about 1 billion items that is with a B. We have 1 billion statutes, regulations, judicial opinions, lawyer-filed briefs, pleadings, motions that we're currently running large language models across to be able to essentially tag up and distill and output, much like Uwais was talking about, the legal data, not just from the United States, but also from the EU, that is from Germany and France, and from the UK, and from Africa, and South America, and Asia. So we're taking all this legal data, this legal oil, and refining it. And of course, my nights and weekends are with a nonprofit that's called Sally. Sally is a legal data standard that I'm going to be talking about now, focused on this. So Sally is, as I said, is a nonprofit, and I am a volunteer for that nonprofit. Everything that I'm going to be showing you here is free and open source. So as far as for the nonprofit nerds, free is in speech and free is in beer. That is, everything in here will be is free for the taking. We're being used by some of the smallest organizations in the world, like Thomson Reuters, like Lexis, like Bloomberg, also by DMSs like NetDocuments, like iManage, and also some small law firms like DLA Piper, Gibson Dunn, Perkins Coie, et cetera. The problem that we're solving for all of these people are the problems that we're solving for companies like Thomson Reuters. Thomson Reuters said, the guy we're working with is Corey. Corey's boss said, Corey, we have a problem. He said, we have 30 products that don't talk to each other. Make them talk to each other. And Corey thought, wow, I'm going to have to build an ontology, a taxonomy, and building that is really hard, especially since I'm not a lawyer. And then he looked to Sally and he said, wow, Sally is a really good ontology. So he's using Sally to be able to be a universal translator between all 30 of those products. So that's an internal problem he's solving. We're also solving an external problem for him, because now he can say, I don't want to be able to map to all of these law firms. So what he's saying to them is saying, hey, if you want to talk to any of those 30 products, send me the Sally tags. And now each one of these law firms, if they want to talk to their products, will send the Sally tags. And now the Sally, those law firms can talk to all 30 of his products uniformly. So that is the external problem. So we're solving those internal problems. My products don't talk to each other. And those external problems for every one of these logos. We're solving that for Intap. We're solving that for NetDocuments. We're solving that for iManage. Everyone has to do kind of a mapping, and no one wants to be able to do individual mappings for every one of their clients. And so what we're doing is essentially creating a pick list. So if you think about on Amazon, I want to be able to select, the animal print things or the camouflage things. For that to work, you need to tag up all the animal print things, and you have to tag up the camouflage things. That helps with finding. So what we're doing is we're helping you find the areas of law. We're helping you find the services. We're helping you find the documents that you care about. And then once you've found those items and tagged them up, that can help pricing. That is, I want to be able to find all of my flat fee, or all of my hourly, or all of my others. So in this way, Sally is doing both the substantive law, what is the area of law, with the business of law. How much do the things cost, and what is my profit? So, of course, it depends is something that lawyers like saying a lot. And whenever a lawyer says to me, well, it depends, I say, it depends on what? Because and once they tell me the answer for that, I add it to Sally. So, for example, how much does a deposition cost? There's an ABA task code in the United States for deposition. And I would say, well, that's stupid to try to find that for pricing, because for the business of law, for pricing, that doesn't tell you, am I taking the deposition? Or am I defending the deposition? Or am I merely observing the deposition? Because those are 3 different price points, taking me a different amount of time. And is it a fact witness? Or is it an expert witness? Or is it a corporate representative, say a CEO? Each of those is going to take a different amount of time. And then, is it a slip and fall case? Or is it a patent infringement case? Because one of those is going to take a lot more time than the others. So these are substantive law questions that relate to the business of law. How much is it going to cost? And it turns out that Sally answers all of those questions. That is, there is a tag for each one of those things that we're going through. So each of these is affecting both the business of law and substantive law in ways that previous tags, that is UTBMS, do not. So when you think about what kind of claim is this, and I guess I'll jump from this point, I'll jump over to being able to talk through and actually show and tell on the standard itself. We have, here is the standard. Each of the things on the standard, and of course, one of the things that we're counting is the area of law. One of the areas of law that we're counting is intellectual property law. And one of the types of intellectual property law is patent law. You might say there are different kinds, and I'm just validating.
You're not sharing. Sorry.
That's that. Thank you for that. I was just making sure, and now it looks like I'm sharing, right? Yes.
Yes.
All right, great. So there are a thing called an area of law. A type of area of law is intellectual property law, and a type of patent law is that. So you might say, Damien, where is patent litigation, disputes, versus patent prosecution, registration? And Sally very wisely separated the area of law from the service that's being provided. That is, am I as a lawyer giving advice? Should I get the patent? And then I file the patent with the Patent and Trademark Office. Then I license the patent. Then I litigate the patent. Then I deal with patent assets in bankruptcy. So you can see how that actually makes a much smarter ontology. Because if I were to have, say, patent law and then have children of that be patent litigation and patent prosecution, I would have to do the same thing for trademark registration and trademark litigation, and do the same thing for copyright registration and copyright litigation. So you have turtles all the way down. So in this way, separating the area of law, patent law, from the service being provided, now you're able to do tag number 1 is patent law, and tag number 2 is the service I'm providing, patent advice. The most important aspect of Sally is what you see here called the IRI. This is a unique identifier for the thing that is patent law. And you can call patent law many things. For example, our German friends could call patent law Patentrecht, right? Or if you're Spanish, or if you're French, or if you're in Israel, or if you're in India. There could be many names for the thing that is patent law, but all of those have the same Sally unique identifier that is described here. And that Sally unique identifier is important because that is the unique identifier that is being used by every one of these companies. So the idea is that if you want to be able to say, hey, Damien, at vLex, send me all of your patent law things, you would send me an API call with this unique identifier. And then I, at Dr. Alarm vLex Fastcase, would send you all of my patent things. And then you could have that same API call with that same identifier and send that to Thomson Reuters. And they will send you all of their patent law things. Send the same one to Lexis, to Bloomberg, to NetDocuments, to iManage, to Microsoft. Everyone on the screen will be counting the thing that is patent law with this unique identifier. So this is the universal standard. No matter how you call the thing, now we're able to uniformly interoperate between all the companies that you see on your screen here. And so you might say, well, that's great. How is it set up? And that's one of the ways that we have set it up is that if I say something false about Alejandro, and that's probably going to happen by the end of this call, Alejandro can sue me for negligent misrepresentation. If you ask 3 lawyers, what kind of claim is negligent misrepresentation? Lawyer 1 would say, well, it's a negligence claim, obviously, and they would be correct. Lawyer 2 would say, well, it is that, but it is also a misrepresentation claim, and they would be correct. And lawyer 3 would say, it kind of is both things, but it is also, Damien is saying something false about Alejandro. Therefore, it's kind of a defamation claim as well. And so how do you settle the argument between lawyer number 1 and lawyer number 2 and lawyer number 3? And the answer is you don't, because all are correct. It is a negligence claim. It is also a misrepresentation claim. It is also a defamation claim. In some jurisdictions in the United States, call this negligent misrepresentation causing harm. All of those have the same unique identifier that is reflected here. So this is a better, smarter way to be able to set up this ontology, because this way, if you run a query for negligence or for misrepresentation or a query for defamation, all roads will lead to negligent misrepresentation because of this multiple parentage side. Now, I could also be able to say, if you happen to get stuck your ship in the Suez Canal, it would never happen, but if it were to happen, you could get sued for maritime negligence. Hypothetically, negligence. Hypothetically, you would ask, what kind of claim is maritime negligence? And it is, of course, a negligence claim. It is also an admiralty and maritime claim that is argued in the forum that is the Admiralty Court, which is part of the area of law that is the Admiralty and Maritime Law. And it is part of the industry that is the transportation and logistics industry. All of these are reflected in what's called a knowledge graph, to be able to say that all of these things are interwoven. So then you can imagine if I'm a law firm that says, I have a new client in the transportation industry. What have we done in the transportation industry? Because we've connected these transportation industry, you can pull in all of the maritime negligence items and then be able to reflect that. We've done these 100 matters in the transportation industry. So this is a way that we can really build this out in a more intelligent way. When you say, how might I be able to start doing this work? This is, you would, in the past, you would do it something like I've shown you here, where Intap is one of the people that is implementing Sally. Intap went through a lot of law firms, and Intap looked at the law firms like Baker Hostetler, DLA Piper, Jones Day, and said, what are they calling their areas of law? And so one law firm calls an area of law appeals to the PTAB. And implementation is largely being able to say, appeals to the PTAB is not an area of law. The area of law, the PTAB is the Patent Trial and Appeal Board. So the area of law is patent law. And because it is appeals to the PTAB, the service that's being provided by the lawyer is the appellate practice. And the PTAB is not an area of law. The PTAB is a forum where items are argued. So taking what kind of is a Frankenstein tag that is three things mashed together and separating them into their component parts. And you can see how that'd be helpful, because then you, as you're running your analytics, can say, show me all the patent things that we've done, or just show me all the appellate things that we've done, or show me all my patent matters in the PTAB. This gives you much more granularity to be able to tag things up rather than kind of this Frankenstein thing that is together. So doing this in the past has been difficult, but it's become much more easy using a tool that we've been showing you here. There is, using large language models, there is a way that you could use a list of areas of law from a law firm. So this is an example of a list of areas of law. And this is a list that actually came up from a law firm that I'm not going to disclose who the law firm is, because this is an embarrassing area of law list. They say that garnishment is an area of law, but it's not. It is a remedy. Gas pipeline, not an area of law. Gas pipeline is a thing that lives in the world. So this is a list that then you can say to the large language model, I want to be able to assign 4 potential areas of law and provide them in columns in the order of highest probability to lowest probability. And look what GPT is able to do. It's able to take this garbage list, things like garnishment, and is able to say garnishment on the Sally side looks a lot like labor and employment law or wage and hour law. Gas pipeline looks like energy law or oil and gas law. And so this is using the power of large language models to connect this garbage ontology to the Sally ontology, which is then able to be used by everyone on the list earlier. And so the way that you can do that even faster now is through this tool that Mike Bomarito from 273 Ventures built, where I can say garnishment. And so then it'll actually pull up the area of law as employment law. And then it will also say that garnishment shows up in our data set as an objective. This is something that I want to do. And then I can move on to my next one. I could be able to say patent infringement is a thing that matters, infringement. And then it could say the area of law is patent law, and the objective, the cause of action, is patent infringement. And so what it does is collects all of these down here. So you can see garnishment is related to employment law, and garnishment actually exists in the world. And then patent infringement is patent law, and patent infringement is one of those. It tells you whether it looked to the large language model or whether it just did a direct mapping of garnishment equals garnishment, and then it just went to the label. After you do that, you can download this as a CSV, and then you could take this and be able to do what I'm showing you in a moment, is to get you rows and columns in structured data of your prior ontology, and then map it to the Sally ontology. So here you can see that we have, as we make it a bit bigger, you can see that it has garnishment is an area of law, and here's the IRI. Here's the unique identifier for garnishment. That is employment law. Garnishment is an item in the world. Patent infringement is part of the area of law, that is patent law, and patent infringement is an objective, that is patent infringement. You could do that with your dozens or hundreds of matter. And so as my 20 minutes go to a close, I'm just going to, in a moment, show that all of this is, as I said, free and open source. So if you go to GitHub, there is all of the XML that I provided I'll show you here. The XML is in a class to be able to show. I showed you negligent misrepresentation. As I get rid of this, and as Microsoft says, pretty please, sugar on top, please let me show LMSS OWL. Here we are. So here is the XML class for negligent misrepresentation. It is a type of negligence claim. I don't care about your release notes, Microsoft. What I care about is LMSS. All right. It is a type of negligence claim. It is also a type of misrepresentation claim. It is also a type of defamation claim. And another name for this is negligent misrepresentation causing harm. All this is reflected in this XML class, and all of that XML is available at GitHub. So here's the LMSS OWL file. That is an XML file that is free and open source. You could download it today. And so Microsoft, Jason Barnwell within Microsoft said, cool, I could just go to the permalink that's here. And every time LMSS gets updated, you can get the most updated version from GitHub. And you can see here that Mike Lamarito added translations for, Sally is founded on US English, and we've now added UK English and Spanish and Hebrew and Indian. And we're adding French and German and all of the other translations so that you'll have full translations and be able to do the work that Uwais talked about earlier. And with that, I think my 20 minutes are about up. But Sally is a nonprofit. Really, you have two options. You could create a taxonomy internally, and that's really hard. And it doesn't talk to anyone. That's option number one. Option number two is you use Sally. And we've done the hard work for you. We've done the hard thinking for you. And we're working with the largest organizations in the world to be able to build a beautiful ontology. And that ontology talks to all of your vendors and all of your clients. So really between option one, building your own, and option two, why would anyone have a telephone that only talks to nobody? Why not have a telephone that speaks to the entire ecosystem? And that's what Sally is.
Amazing. Thanks a lot, Damien. It's a real privilege when we are part of this. I feel privileged to be providing such great education and instruction, knowledge materials. It's great to what you have done, both of you. So good news and bad news. The good news is that there is a recording for everybody because there is so much material in today's presentation. So there is a recording. And second good news is that the speakers might comment and might share some of these materials in the comments under today's event. So for instance, the GitHub, or maybe many of the materials that Uwais was mentioning, and or just simply following him also. There is a lot of cooking and gardening. So if I may, because there are many questions, if I may start with one that we haven't rehearsed this, but I think this is key. You both we're talking about skills, and these it's impossible for anybody to have a lawyer's mindset plus data scientist plus knowledge management. So we have to collaborate. That's my point here. We have to collaborate. You have been consulting law firms and in-house, developing or introducing the digital transformation. If you could list or recreate the best potential team you would like to work with, implementing or structuring the data, as in the case of Uwais, moving forward one of these experiments of proof of concepts, or in the case of Sally, what are the skills and the people you would like on the team to be sure you are successful?
Uwais, would you like to start? I've been talking for a long time.
Sure, yeah. Give you a chance to catch your breath. Awesome presentation, Damien. So I think it's an interesting question, but I also think it depends on context. I think the most important part is coming with a humble perspective and realizing that no one person can answer all of the questions when it comes to these conversations about applying AI within the legal space. And when you come with that perspective, you have to come with a perspective that you want to help everybody else who's coming from different skill sets, different domains, different experiences, bring their best to the table in doing what they do, and respecting them in terms of their skill and knowledge. Like for me, for example, I'm a data scientist. I'm not a lawyer. I've never studied law. I've never practiced as a lawyer. So when I enter into a conversation with someone who is a domain expert, then I see them as a domain expert, and I bring my expertise from the technical perspective, and they bring their expertise from the legal perspective. And I think it's, like you said, just coming with that collaboration, bringing that approach and multidisciplinary kind of approach to working on these types of projects. In terms of the best team, I think that's an interesting question, because for these types of projects to be successful, you have to bring along the laggards within the organizations. And I don't mean laggards in a bad way. I mean the people who are more conservative and who are more worried about risk, etc. For these innovative types of projects, you have to bring along the people from the IT departments. You have to bring along people from the information security teams. You have to bring along people from the data protection teams, because it's so complex that these concerns were almost siloed just by nature of where they are. But with AI, because everything's been brought together, it kind of stems across technology, content, data, infrastructure, as well as business of law, practice of law, etc. So it's bringing all of those conversations in a way where everybody's trying to drive forward that transformation.
I would agree with that. And to build upon it, there's the subject matter experts really do their role, as Uwais said. And of course, they work with the other members of the team to play their role. I would say for the subject matter experts on this call, that is the lawyers and the paralegals and the people that have subject matter expertise, the domain expertise. I would say the real question is, what do you care about? That is, what are the tasks that you need to get done? And what are the tags for those tasks to be able to do those things that need to be done? And then you could provide, and of course, a nice menu of those tasks is Sally. So you can work with your data scientists and your technical team to be able to say, of Sally's 13,000 things, let me pick amongst those which things really matter for those tasks that I need to get done. I want to collect merger agreements with force majeure clauses in Tanzania. Each of those is a Sally tag. And then you could say, those are the things I care about. And then you can work with the data scientists to be able to say, where can I extract those tags? How can I extract those tags from the various documents that are in there? So really that merging of domain expertise, what do I care about? What are the tags for the things that I care about? And then how do I extract them from the data is really where the melding of the domain expertise with the technical expertise happens.
I think that's an interesting point, because the part of the challenge is because everybody comes from different domains, they speak different languages. So there's almost a need to create like a common shared language, that what's happened with Sally. But in the AI space, we've been trying to do some of that work in terms of what's the shared language we all need to have that meaningful conversation. Because if I'm, as a data scientist, using a technical term like few-shot learning, nobody's really going to understand what that is. So it's, for example, just being conscious of what's technical lingo and being able to translate that into a more an easier way to understand. So I think part of that is bringing that shared understanding through kind of like common frameworks and having that ability to translate.
And one of those examples on the domain side, so I love the few-shot learning versus zero-shot learning, right? Those are something that Uwais and I, we live for, but I would bet a lot of the people on this call are saying, what do you mean few-shot, zero-shot, right? So that is ambiguities on the technical side. There are ambiguities on the domain expertise side that someone might say, I care about demurrers, DEMURRERS. And that person might know that a demurrer is what everyone else in the United States calls a motion to dismiss a case. But in California, it is called a demurrer. And so really building that into your model, like Sally has, if you do the thing that is motion to dismiss, it has a synonym that's called demurrer. So if Uwais is running through his parsing model, he's going to pull in a demurrer and say that is a type of motion to dismiss. But that is a way on the substantive side that is much like zero-shot and few-shot. There might be a loss in translation, but if you can build that ambiguity into the model, like Sally has, that reduces the friction of those things.
Excellent. I would love to be part of that team then. So wrapping up, unfortunately, it's 1 minute left. There are many more questions. The good news is that that the tables are, we have 4 webinars and 2 physical seminars in October. So hopefully we are going to be discussing some of the ethical and questions and data analysis questions that some of the attendees are writing about or asking about. Thanks a lot to our speakers today. Excellent job. Looking forward to continue the conversation also in the comments, if you could provide us with some additional materials. And maybe I would like to looking forward to see you in Madrid, maybe at the end of October. And for the rest of the participants, thanks a lot for being here, and looking forward to see you next Wednesday talking about generative AI and real applications for law firms. Thanks a lot.
Great. Thanks, Alejandro.
Thanks,
everyone. Bye.
Ciao, ciao.